Yet, all around the stuff that makes up our everyday world is something just as important, but far more mysterious. The space in which all this stuff exists. To get a feel for what I'm talking about, let's stop for a moment and imagine. What if you took all this stuff away? I mean all of it. The people, the cars and buildings, and not just the stuff here on Earth, but the Earth itself. What if you took away all the planets, stars, and galaxies, and not just the big stuff, but tiny things down to the very last atoms of gas and dust? What if you took it all away? What would be left? Most of us would say nothing, and we'd be right. But strangely, we'd also be wrong. What's left is empty space, and as it turns out, empty space is not nothing. It's something. Something with hidden characteristics as real as all the stuff in our everyday lives. In fact, space is so real, it can bend. Space can twist. And it can ripple. So real that empty space itself helps shape everything in the world around us and forms the very fabric of the cosmos. Not light bulbs and street lamps, but the very nature of light itself. And it was his fascination with one particularly weird feature of light, its speed, that would lead Einstein to overturn Newton's picture of space. To see how, let's take a ride. But now imagine that instead of measuring the speed of the cab, you have a radar sign that measures the speed of the light coming off its headlights. That sign would measure the light traveling at an astounding 671 million miles an hour. Now, when the cab starts moving, you'd think that the speed of the light would increase by the same amount as the car. After all, you'd think that the moving cab would give the light an extra push. But surprisingly, that's not what happens. Our radar sign, or any measurement of light speed, will always detect light traveling at 671 million miles per hour, whether the cab is moving or not. But how could this be? How could all measurements of light speed always come out the same? So here's how Einstein made sense of this extraordinary puzzle. Knowing that speed is just a measure of the space that something travels over time, Einstein proposed a truly stunning idea, that space and time could work together, constantly adjusting by exactly the right amount, so that no matter how fast you might be moving when you measure the speed of light, it always comes out to be 671 million miles per hour. If space and time being flexible sounds unfamiliar, it's only because we don't move fast enough in everyday life to see it in action. But if this cab could move near the speed of light, the effects would no longer be hidden. For example, if you were on a street corner as I went by close to the speed of light, you'd see space adjusting so that my cab, it would appear just inches long. You'd also hear my watch ticking off time very slowly. But from my perspective, inside the cab, my watch would be ticking normally, and space in here would appear as it always does. But when I look outside the cab, I'd see space wildly adjusting, all to keep the speed of light constant. So with Einstein, time and space are no longer rigid and absolute. Instead, they meld together with motion, forming a single entity that came to be called spacetime. This was a truly radical break from Newton. Think of this table as space-time, and think of these balls as objects in space. Now, if space-time were nice and flat, like the surface of this table, objects would travel in straight lines. But if space is like a fabric that can stretch and bend, well, this may seem a little strange. But watch what happens if I put something heavy on the stretchy space-time fabric. Now, if I take my shot again, the ball travels along an indentation in the fabric that the heavier object creates. And this, Einstein realized, is how gravity actually works. It's the warping of space-time caused by the objects within it. In other words, gravity is the shape of space-time itself. The moon is kept in orbit not because it's pulled to the Earth by some mysterious force, but rather because it rolls along a curve in the space-time fabric that the Earth creates.
A bottle of water that has holes in it, right? So of course the water is spraying out of the holes because gravity is pulling on the water, right? But if Einstein is right, if I drop this bottle, the water will no longer feel gravity, so the water should stop spraying out. So let's see it. 3, 2, 1. Whoa. Wow. Come on now.